Hello students, today we were going to be going over our prerequisite skills for chapter H1. This is honors vector packet and we need to go over these prerequisite skills. So the first thing we're going to do is have you go to page H1, simplifying radicals. Okay, so it says perfect square numbers and they list all the perfect squares here. So that's 2 squared, 3 squared, 4 squared, 5 squared, etc. So you should have all those numbers memorized for now, all the way up to 12. So we are going to go ahead and simplify this radical, okay? A radical is a square root. So we want to simplify this radical using the tree method. So this 60 is called the radicand. The square root is called the radical, okay? So here's our first step. Work only with the radicand. So with the 60, split the radicand into two factors. So I say what times what is 60? 30 times 2. Okay. So we are going to keep splitting until all of them are prime numbers. 2 is prime, so I'm going to circle that. I'm going to break 30 down into 15 times 2. And 2 is prime. 15 is not. So I break 15 down into 3 times 5. Okay, both of those are prime, and I'm going to circle them like they're on a factor tree and they're my little cherries. Now, if in this particular radicand, or you can think of it as a little bit of a cage, and the only way you can get out is if you can find a buddy that looks like you. So these two go out, they make their way out, and 1 doesn't quite make it. So say goodbye to 1. 1, 2 makes it out. So it's 2 square roots of, there's no pair of 3s, no pair of 5. So these stay in the gel. They don't look alike. So 2 square roots of 3 times 5 is 15. We multiply it out. And that square root of 60 simplified is 2 square roots of 15. Now, let's do a little bit bigger one because that one was so much fun. Which one should we do? Should we do the 250? We'll jump to that one. Okay, first of all, break it up. 10 times 25. Okay, neither one of those are prime, so I'm going to break it down again. 5 times 2. 5 is prime, 2 is prime. 25 breaks down 5 times 5. Prime again. Okay, so these two are buddies, so they get to go out. 1 goes out, 1 dies trying to escape, bye-bye. So you're left with just the 5 times 2. So the 5 escapes, and the 5 times 2, you can't go out in triplets, no way, you only have twins go out. So 1 makes it, 1 doesn't, and then 2 times 5 is left under the radical. So you're left with 5 square roots of 10, and you've simplified 250. Okay? Next, I'm going to have you finish those. We can pause the video and have you work on that. Next thing we're going to do, we're going to go on to I'm going to go a little bit closer here. Hopefully you can still see that okay. Divisibility rules. Okay, if something's going to go into 2, it just has to be evens in the ones place. So 6 is even, so that's divisible by 2. No example means that's a non-example, means that ends in 9. 2 doesn't go into 9 evenly, so that is not an even. 2 does not go into that number. 3, all you do is the sum of the digits. That means 8 plus 0 plus 7 equals 15. 3 goes into 15 evenly, so that 807 is divisible by 3. If I add these 3 together, I get 16. 3 does not go into 16 evenly, so it does not work for 3 divisibility rule. 4, the last 2 digits here, the last 2 is 16. 4 goes into 16 evenly, so yes, that one is a good example. 4 does not go into 41 evenly, so that's a non-example. 5, if it's the 5 or 0. See, we should know that, have that memorized. 6, if the number is divisible by 2 and 3. So we use both of those rules. The last number has to be an even number, and the last, and if you add 3 plus 4 plus 2, that's 9, and 3 goes into 9 evenly, so 342 is divisible by 6. And 6 plus 5 is 11. 3 doesn't go into that, so that will not work. 8, if the number formed by the last 3 digits is divisible by 8. So if I take this, 3 goes into 32 4 times and into 8 once. Or did I say 8 goes into 32 4 times and 8 goes into 8 once. So if the last 3 digits are divisible by 8, then yes, it works. And evidently 147 it does not. The sum of the digits is divisible by 9. 6 plus 2 plus 1 plus 9 is 18. 9 goes into 18 evenly. 5, 5, 5, 15. 9 does not go into 15, so that doesn't work. 10, if the last digit is 0, it works. So we're going to go ahead and see, is 20 divisible by 4? Yes. Is it divisible by 9? No. 16? No. 25? No. And that just goes 4 times 5 equals 20. And next one is 75. Does 4 go into 75? Let's see the rule up here. The last 2 digits, 4 does not go into 75 evenly. Let's see, 4 into 75. We can do the work here. Or I don't care if you just use the calculator. 1 goes 4, 35. And 4 does not go into 35 evenly. So go ahead, and so it's not 4. 9 does not go into evening. 16 does not. If 4 doesn't, then 16 won't. 25 does. And we go 25 times 3. Okay. So again, we could say 25 times 3. If you were doing a square root, you'd do some extra work, but use the divisibility rules to determine if the numbers, okay. All right, so it just helps you to know that these numbers are divisible by some of these that are perfect squares, okay? Go ahead and finish that one. You can pause the video, and then we're going to go on to the next page, H3, Pythagorean theorem, which is in so in a Pythagorean theorem, okay, first of all, you may need to number the problems. 1, 2, 3, 4, because they're not numbered there. Here's our first one. Okay, so the Pythagorean theorem says in any right triangle, so you have a right triangle, A, B, C. C is your longest side or your hypotenuse. A squared, this side squared, plus this side squared is going to equal C squared. So if you forget where the hypotenuse is, you put yourself in the corner, sit down, and look out. And when you look out, that's going to be your hypotenuse when you look out. So we say this is A, this is B, and this is C. So we say A squared, 7 squared, plus B squared, 7 squared, equals, and I'm going to put X squared. Okay, so 7 squared is 49, plus 49 equals X squared. Okay, 49 plus 49, 9 and 9 is 18, carry the 1, 98 equals X squared. Now, okay, so you have to square each number, add them together, and then to solve for X, you have to take the square root of each side. Okay, and if you're going to break 98 down, you know it's going to be 49 times 2. So 98 is, and again, you're taking the square root, 49 times 2, and 49 breaks down into 7 times 7. So you can, it comes out in pairs, 7 comes out, 1 dies on the way out, and it's 7 square roots of 2. That's what you're left with. And I know that's kind of messy, so I apologize for that, okay? This one should be a little bit better here, 15, 9, and X. So again, the hypotenuse is the one across here. So we say 15 squared plus 9 squared equals X squared. 15 squared, you can take your handy dandy calculator. 15 squared, 225, plus 81 equals X squared. So 225 plus 81 is 306. Now, if we use our divisibility rules, let's see, I know 3 will go into that because 3 and 6 is 9. I'm just trying to remember if 9 goes into that. So 306 divided by 9 equals 34. So I could go. So then I take the square root of each side to solve for x. And then I'm going to break this down into 34 times 9. And then this goes to 17 times 2. 17 is prime, 2 is prime. 9 breaks down into 3 times 3. So these are our cherries because they're all the prime numbers. So then we say x equals 3 makes 1 out, and 1 dies on the way out. So 3 square roots, and we have to multiply 17 and 2, 3 square roots of 34. Let's see, were we supposed to do something else here? Trying to think if we were supposed to estimate a number on that. And let me see where that paper went. Oh, here it is. To find the length of the hypotenuse, simplify, radical, and estimate. So we simplified, but we did not estimate. So I don't know exactly what they want us to estimate. We could go 2 square root times 7, or we could just say 98 square root is 9.89, so we could estimate that to be 9.9 on that one. This one over here, square root of 306, is 17.49. And so when you estimate and it's not exactly equal, you use the squiggly lines. Okay. And we don't have any units, so we don't use inches, feet, or yards. Okay. Last one, distance formula. Number 7. Okay, our x1, y1, I'm going to name it zeros, 0. And x2, y2 is at 2, 2. So I use this formula, square root of x2 minus x1 squared. So x2 was 2 plus minus 0 squared plus 2 minus 0 squared. I want to make sure you could see that. What does that equal? Square root 2 squared plus 2 squared equals square root. 2 squared is 4 plus 4, which is the square root of 8. Okay, and when you take the square root of 8, it equals 4 times 2, and 4 breaks down into 2 times 2, so you see that's a perfect square. 2 makes it out, 1 dies on the way out, so you're left with 2 square roots of 2. And if I just go 8 square root, I get 2.83 as approximately equal to 2.83. Okay, that one's a little bit easier because it goes from the origin. Okay, number 8, and again you should number all of these on this paper, is a little more challenging. It's at -3, 3, and then it's at 5, 2. Okay, so I can go x2, y2, x1, y1, and you could pick either of these, but you just have to make sure if this one's x1, that's one's y1. Okay, so we put it in the formula. Distance equals, okay, x2 was 5 minus x1 is a -3. Remember, when you subtract a negative, it's going to become plus positive. Plus y2 is 2 minus y1 is 3. Okay, so the distance equals square root of 8 squared plus -1 squared. Okay, distance equals 64 plus 1. Okay. I know you can't read that very well, so it's the square root of 65. And that breaks down into 5 times 13, I believe. And so you can't break it down any more than that, other than approximately equal to 65 square root is 8.06. So approximately equal to 8.06. And you're done. Okay, students, you can do this. You rock.